At the end of our last video, we had obtained a congruence, A is congruent to Q times B plus R, and we had made replacements for the values of A and B in this congruence with zeros via our work on the previous slide. Now we didn't make any replacements about the values of Q and R mod D because we don't know the values of Q and R mod D. However, it's not particularly important because if I take any old integer and I multiply it by 0, the resulting integer is going to be 0. So this Q times 0 just simplifies to a 0 right here. And if I take any integer like R and I add 0 to it, that doesn't change the value of R. R plus 0 is R. Combining those things together, I can conclude that the right-hand side of this congruence is just R, and the left-hand side of this congruence remains 0. And ultimately, R is congruent to 0 mod D. Now, if you'll remember the lemma that we used on the previous slide, we took the statement D divides A, and we translated that to A is congruent to 0 mod D. We were using part of that lemma that we've discussed previously to say that if A is divisible by D, then A is congruent to 0 mod D. That statement is an if and only if statement, which means we could travel it in reverse as well. In other words, because R is congruent to 0 mod D, we can conclude that R is divisible by D. And this is truly a conclusion. We're concluding that R is equivalent to 0 mod D from this statement, and then applying that theorem that we used previously in reverse, we are concluding that R is divisible by D. Now we're almost to the end of the proof of this part of the lemma, and so what I want to do now is insert a black statement, which is going to be an observation statement. I want to work with my reader to draw their attention to something. And so I'm just going to point out something about what we know about D at this moment. All along, we've known that D divides B. That was one of the things we had on our previous slide. D divides B. What we've just worked so hard for is to show that D divides R. That was this red line right here. So right here I'm inserting this black statement to note that D is a number that not only divides R, which we just showed, but I'd like to remind the reader that D also divides B. That's particularly important right now because where we're ultimately headed is we want to come up with a relationship between E and D, and E is the greatest common divisor of B and R. Using the definition of the greatest common divisor of two integers, we know three things about E. And the three things we know is that E divides R, E divides B, and furthermore, E is the largest thing that does 1 and 2 here. So what have we done? We've just pointed out to the reader that D is a thing that divides R, and D is a thing that divides B. By part 3, right here, we now get that final red line that we're looking for, which is that because E is the largest number to divide both B and R, and D is some number that divides both B and R, it must be the case that D is smaller than E, which was the goal that we set for ourselves of this direction. So this is the big punchline, and you can see some things that happen here when we go back to the previous slides. We used 1 and 2 of the assumption about D very heavily working at the start of this proof. We then used part 3 very heavily in drawing this final conclusion in order to get that relationship between D and E. And so you can start to see why it's so important to write down absolutely everything you know in a proof. If you're not using absolutely everything you know, that could be a reason why you're stuck as you're working through proofs, trying to prove them on your own. Now, we're not yet done. We've only done half of what we set out to do. We proved that D was less than or equal to E. We have not yet shown that E is less than or equal to D, and we've already done a whole lot of work. So originally this lemma can seem super daunting. You might in your head even say, how on earth is this a lemma? I've already written 2 whole pages worth and I have 2 more pages yet to go. However, this is something that's beautiful about the power of writing proofs so abstractly with all letters. They're done so generally. In fact, what I'm going to use as a quiz for us this week in our abstract algebra class is I'd like you to go back over the proof that D is less than or equal to E. The proof that E is less than or equal to D is so similar, you should be able to basically just cross out certain letters and change them to other letters, and you'll have the proof that E is less than or equal to D. You don't need any new ideas. Everything you need is contained in the slides prior to this. You just need to change some of the letters and the way in which you make some of the references. So that I'm leaving as an exercise to the reader. For my watchers at home who are enrolled in my abstract algebra class, I'm going to count this as a quiz, and I'll post that on our learning management website. Just in summary, here are some things that I hope you got from this set of slides. First of all, when we were writing a proof, we were writing. Everything was written in full sentences, and it was all typed here for presentation, so the writing was neat and clear. Whenever you're doing something in a proof, you always want to justify why you're doing that. You want to justify the definitions, the theorems, and the properties that you're using. What definition is important? The definition of Scotland, the definition of a whale, or the definition of the greatest common divisor of 2 things? Similarly, what theorems are you using? For us, we haven't covered a lot of content right now, so I could say we had a lemma about divisibility, but you might want to be more precise about that. If you're using your book as a reference, you could say, I'm using lemma number 2.5 in Galleon, or something of that nature, to make sure your reader knows where to go if they need more information about that theorem. If you're using a distributive property or a property about 0, say that property to make sure that your reader understands. Because all in all, the purpose of proofwriting is not to sound like you're a genius. The purpose of proofwriting is to be persuasive to somebody else who's at the same level of learning as you. You're not trying to impress a room full of PhD mathematicians. What you're trying to do is have a persuasive conversation with somebody of the same caliber as you. So in general, writing more and writing helpfully is a lot better than leaving things out to try to sound like you get it.